This video is going to talk about the extra stuff that the halogens do. There's another video that talks about the orange and the blue polyatomic ions, which I call the bus and the loop. And this section right here with the P and the S for public school is the bus. And then this section over here is called the bus loop. And then we have the annex. This video is talking about the extra stuff that the halogens do. And that's this area up here. The halogens do this extra stuff, which only the halogens do on this chart. And they do 4 things instead of just the 2. If you watch the other video, where you've been in class, you'll know that the orange ones are O4 when they say 8. And then they're O3, 3 oxygens, when they have the ending -ite. And that's all that the orange ones do. There is 4 things that these special blue ones, which are called the halogens, that's their family name. They're one away from the noble gases, and they are only missing 1 valence electron. So since they're 1 away, they have a -1 charge, and they do 4 things. So they have the normal O4, they have the O4, which is going to be a per 8, per whatever the element's name is, 8. They have the normal O3 that the blue ones do, which is whatever the element's name is, 8. They have their typical 1 down, which is whatever the element's name is, -ite. And they also have just having 1 oxygen, which is a hypo, and I have a way to remember this, the hypo-ite variety. I've already learned the 8s and the ites, so those aren't new to me. I knew that the 8 was the top of the line before, when it was on the non-exceptions, when we were just talking about basically the rules, and that if I was the larger amount was because I ate, so I got larger. Still, I'm larger yet, and I'm still the 8 ending. So both of these have an 8 ending, which works out with when I have more oxygens, my ending is 8. The other way I remember these new things is having to do with going down. So when I went 1 down, I became -ite. When I went 1 down, I became -ite. So then I say, what's it called when you are cold and your body temperature goes down? Like when you fall in a frozen lake or something. You suffer from hypothermia. And the hypo is because your body temperature is going down. So when the oxygen goes down yet 1 more, that's the hypo version of these polyatomic oxyions that the halogens do. So let's use some of them, the halogens, in naming. And there is another video on just naming, but I'm going to be naming with the halogens here. So to write the name of the formula, to create the formula, you write the symbol and its charge. Potassium is in the +1 column, and it's in the first column way over there on the opposite side of the periodic table that's cut off. And the chlorate is right here. So what's the ending on that? The ending is 8. And I remember that when the bus loop says 8, that's when the ending is O3. So that's Cl for chlorine and O3. And of course, I know it's charged, as always, and everybody in the halogens column is -1, no matter what kind of ion they're creating. So then you do the drop the signs, drop it down, switch and simplify. So basically what's happening is the charge from there is going down to be a subscript, and the charge from there is, and we don't write the number 1. So this is K, and the K is getting the 1, which we don't write, and the ClO3 is getting the 1, which we also don't write. Now be careful, this is just because it's hard to write with the mouse. That's a lowercase l, and this is an uppercase O, and those are some of the things that will get you. So it's K, ClO3, potassium chlorate. Another example is using the new per prefix on the name. So we'll do calcium. That's a Ca for its symbol, and it's a +2 charge. A perfluorate is the extra thing that the fluorate does. Now I knew if I was just the fluorate, I was O3. So the perfluorate is even one more, and so it is F for fluorate and O4. Still got a -1 charge. So when I write this formula and the charges become the subscripts, Ca gets the 1, which I do not write, and the FO4 is going to get a 2. Now if I were to simply write a 2 here after, that would be confusing because it would look like there's 42. So that's why we put this in parentheses before putting out our subscript of 2. The way you know is if this number here, the charge on your cation, is any number other than the number 1 after it's been reduced, you're going to have to employ parentheses in your naming. Let's do another one. I've got barium, B, A, and it too is in the second column, so it's a +2. And now we have a hypo-iodite. I remember that one is the one that's hypothermia, so that's even another 1 down. It's the lowest thing that the halogens do. This is iodine, so it's an I-O, and it was IO2 when it was just iodite. So when it's hypoiodite, it's just IO and it's 1, but we don't write 1s. Once again, it's got a -1 charge. So the BA is going to get the 1, which we don't write, and the IO is going to get the 2. Now, once again, we've got to put that in parentheses, because if we don't, I'm going to show you that you don't write what you intend to write. This is barium and hypoiodite. If I would have written, now this is wrong, if I would have written barium and I wrote my IO and I gave it a 2, then what really would I have said? I'd actually be saying barium, and then this would be just plain old iodite. And you see, that's not what they told me to write. They told me to write hypoiodite, which means that's why I have to have this parentheses around my hypoiodite ion. That way I know that that is hypoiodite and not iodite. Let's try just sodium iodite. The symbol for sodium is Na, and its charge is +1. It's in the first column. So I've got Na +1. And iodite. Iodite, it's iodine. And iodate is IO3. So iodite, which is ite version, is IO2. And it too is a -1 charge. So Na is going to get the 1, which we don't write. And the IO2 is going to get the 1. And because we don't write it, there are no parentheses. So the formula is NaIO2, sodium iodide. So I hope this helps. Please feel free to come to tutoring if you still need additional help.